All right, so here we go. We're gonna do a circle. First, we're gonna set this up at 6 inches right there exactly. You can see it, right?
Yeah.
All right, set up at 6 inches.
But hold on, what are we doing real quick?
So
what's the concept?
So we're defining pi. Pi is actually 3. It's not 3.14, and I'm gonna show you why the radians are wrong, and I'm gonna show you exactly what's going on. I'm gonna give you a perspective of what's really going on with this. Let me show you real quick. Let's do this circle, which radius is 6 inches. Right? So we know for a fact that that's six inches because we can measure it and double check. That's 6 inches right there. All right. So we just did a 6-inch radius circle. Now I am going to draw, without moving the compass, I'm going to draw a radius that is curved, that is not straight. That's our new radius. All right. It's not curved, it's straight. I mean, it's not straight, it's curved. All right, so from here to here, that's 6 inches. Now we're gonna do a straight one. Boom. Those both are 6 inches. All right. So now, when you're doing the radians, they usually grab this straight line and they'll bring it out here and then they'll fold it and they'll tell you that's 57 degrees point something, right? Then there's a problem with that. Once you grab a straight line and you bend it, you lose distance from point A to point B, and I'm gonna show you what happens. Now, if I use a curved line, this curved line fits perfect in this segment of the circle. This curved line is gonna fit perfectly. I don't have to bend it. I just grab it, and it's 6 inches. It's the same distance from here to here in the straight line that from here to here in the curved line. If you do it, they will both arrive at the same location at the same time. So now let's go ahead and show you what's really happening with the radians, and really why are they wrong. All right. So we got 6 more inches, the same as the radius. And since I cannot bend that line, I cut a little piece of wire that's 6 inches long. I'm gonna put it right here so you can see it. This one is a tiny bit. Let's cut the tiny bit up. All right, let's try it again. All right, there you go, 6 inches, right? Now, to show you what's really happening when you use a radius with a straight line and you get the wrong number for pi, it's because when you bend a straight line, you're gonna lose distance. Now, can somebody mark that for me, please? See? Mark it right at the... All right. So we bent that 6 inches line and we lost distance. This is 57 degrees point. This is a radian. There's digits here. All right. This is radians. Now I'm going to show you that when you use a curved line, you don't lose any distance from point A to point B, and it still remains 6 inches, and it will give you a perfect ratio of the radius to the circumference. All right. So now let's do that. Right, I show you that that straight line, that 6 inches, fell short. Now this one, I haven't touched the compass, it's still at 6 inches. Voila, there you have it. That's 60 degrees right there. All right, this distance from 60 degrees to 57, that's pi's 0.14, blase, blase, blase. That should not be there. When you use a straight line, that's what happens. You lose distance. When you use a curved line, you don't lose distance. This is gonna be perfect geometry. Now we're gonna have 3 equilateral triangles on top and 3 on the bottom. That gives you pi is 3, and then 2 times pi is 6. The golden ratio is actually 1/6, or 1/2.6. That's what we have going on right here. Let me finish this real quick so you can see what else we can get going on. Still 6 inches. And we're gonna keep going around, and I'm gonna show you that the radius that's curved is going to fit perfectly 6 times on this circle. We also got the flower of life. Just tells you this is perfect geometry. And now we're gonna draw on top of that the hexagon. And it's too easy. You're gonna see how this fits perfectly. So if you know geometry, you know a hexagon has 6 equilateral triangles inside of it. So 3 of them, that's pi. 3 more, that's the whole 2 times pi. It's something so simple. Why would you use a straight line to draw the radius on a circle? Circle is curved. Use a curved line. And it's still the same distance. We can prove it right here. You see, this line is straight from there to there 6 inches. This line is curved from there to there 6 inches. Same thing here on the corners. From here to here, that's 6 inches. From here to here, that's 6 inches. Everything is perfect. Everything remains. Pi was wrong all along. The radians are wrong. And this is how you solve pi.